Hi, Honors Algebra 2. I just am going to start this video by just saying that I miss you guys. I feel like I've said this in every video, but making videos is really not the same. And it's been sad not to see you guys. So, I know that we have office hours and stuff and just maybe pop in, say hi, and I don't know. I just, it's sad not seeing you guys every day. So I hope you guys are doing well. And um, I'm over here doing the same thing and you know working on a puzzle, same one that I started a while ago. So I haven't gotten too much done with it, but I am trying to. I've just gotten a lot of TV in, and since I don't have Starbucks anymore, I've been making a lot of my own coffee. So I've been trying to make that better. And we're going to finish with 6-4. I told you it was kind of a beast, and it truly, truly is. So here we go. I'm going to take a sip of my coffee, though. Okay. So without using a calculator, find the exact value of each expression by using special right triangles and reference angles. So this is new territory for us. We're basically everything we've done up until this point has brought us here. So what we're going to do is I'm going to write some steps down, and I know it's kind of tight over here, but I'm going to write the steps here. So your first step, whenever you're finding okay, these we don't know, right? These are all greater than, these are all from not 0 to 90. We've been only dealing with 30, 60, and 45. And technically, all of these are 30, 60, or 45. We just haven't gotten to that yet. So what we're going to do first, your first step is to think about what quadrant is the angle in. And so the reason we want to know what quadrant the angle is in is because that's going to then tell me, it's going to tell me the sign of the trig function. So it tells me the sign, if it's plus or minus. Oh, there's that freaking glare. Okay, so it tells me the sign of the trig function. Okay, so then the next step is figuring out, once we've figured out what quadrant it's in, the next step is to figure out what is the reference angle. So the reference angle will tell me then what special right triangle to use. So it tells me what special right triangle to use. Okay, so we're going to start with sine of 240. So sine of 240, like I said, first question is what quadrant is the angle in? So we know that, we have our thing right here. We have our coordinates, and we know, okay, we have 0, 90, 180, and 270, and then of course 360. So 240 is going to be in quadrant 3. Okay, so that's the first step. So then we want to think, okay, if it's in quadrant 3, what is the sign, S-I-G-N, like positive or negative, of sine? Now remember our little like acronym thing. All students take classes. And so in quadrant 3, tangent is the only one that's positive. So that tells me that sine theta is going to be negative. So then my second question, that starts us off. My second question is, what's the reference angle? So the reference angle, remember from the last video, we think about where is 240. 240 is in quadrant 3. So in quadrant 3, the closest x-axis is going to be 180. So what we're going to do is we're going to go 240 minus 180. And 240 minus 180 gets me 60 degrees. So what we're doing is we are putting then these two things together. So we're going to use our 30, 60, 90 triangle. We're going to use the 60 degrees, and we're going to go 1, rad 3, and 2. And so we're looking at the 60 degree because that's my reference angle. We're labeling this opposite, hypotenuse, and adjacent. And then from there, I can answer the question. So sine of 240 is equal to negative because sine is negative. And then sine is opposite over hypotenuse, so negative rad 3 over 2. And that's it. That's my answer. So because really what's happening is, and I'm going to draw this out a little bit. I'm going to get my whiteboard because I know everyone's really excited to see that. But what is like really what you're seeing is, so if we have our coordinate plane there, 240 is like, let's say right here. Right? And so what we're doing with the reference angle and why we need it is because what we're essentially doing is drawing a triangle. And we know, okay, this is the 60 degree angle. And so the 60 degree, that must mean, okay, like then we can use our 30, 60, 90 like ratios to help us. And so that's all that we're doing by using the reference angle and figuring out what quadrant it's in. But again, if you guys have questions, because I know that this can be a lot, if you guys have any questions, I'm happy to help you guys during office hours. So please, stop in, ask away. You guys can email me separately, whatever you guys need. I'm happy to help. Okay, so number 6 is now giving it to us in radians. Now, 7 pi over 4, like we don't know that one off the top of our heads. But one thing I will say, and we'll talk a lot about this tomorrow. Not tomorrow, I don't know. Like days are crazy. Like the next video, I don't know. I could be making the video today. I could be making it tomorrow. I don't know anymore. But there's a pattern to like actually radians are nicer than degrees because I can tell just by looking at this that this is a 45 degree reference angle. But I'll explain that, like I said, in the next video, which will make it nice too. But we'll talk about it on this one too. So the first thing we've got to figure out is what quadrant it's in. So to do that, it's, tomorrow, it's like I don't know. The next video in the unit circle conversation, I'll show you like there's a pattern to figuring out what quadrant this is in. But for right now, if you guys want to figure out what quadrant it's in, we can convert it to degrees. So we're just doing 7 pi over 4 and then 180 over pi to get rid of the radians and convert it to degrees. Sorry, guys. I feel like I'm like I'm like all over the place with my brain. But okay, so I would do 7 times 180, dividing it by 4. That gets me 315. So 315, I think, okay, well, what quadrant is that in? We can look over here. 315 is going to be in quadrant 4. And cosine, well, cosine is actually positive in quadrant 4. All students take classes. This tells me cosine is positive. So that means my answer is going to be positive for this problem. Okay, now let's figure out what the reference angle is. Okay, so the reference angle, if it's in quadrant 4, remember you're always going back to your x-axis. So if I'm going back to my x-axis, which is 360, that's the closest one, I would do 360 minus 315. 360 minus 315 is 45 degrees. So that means if my reference angle is 45 degrees, I'm going to draw a 45, 45, 90 triangle. And I'm going to get my answer. So we're looking at 45 degrees, looking at opposite, hypotenuse, adjacent. We know cosine. Cosine is adjacent over hypotenuse. And then we need to rationalize our denominator. So our answer, remember, we're finding what cosine of 7 pi over 4 is. It's positive. And then we rationalize the denominator, so it's a positive rad 2 over 2. And that is my answer. So before, when I was like, I'm going to talk to you guys about it in the next video when we talk about the unit circle. So there's a pattern here, and one of the patterns is looking at the denominator. Remember that pi over 4 is always equal to 45. Anytime you see a denominator of 4, so you see a denominator of 4, that's going to tell you quickly that the reference angle is 45. So that denominator is going to tell you the reference angle. And it kind of is this, not kind of, it is the same for the other ones. Like we know pi over 6 is 30 degrees. So without doing anything, this one, I know the reference angle is going to be equal to 30 degrees. But again, I'll show you guys the work here. I know with this one that the reference angle is going to be 45 degrees. If the denominator was 3, we know pi over 3 is 60 degrees. So if the denominator was 3, we know that the reference angle is 30 degrees. So that's why I was like, radians are super nice because there's a ton of patterns. Now, you can also tell what quadrant that's in, but it's easier for me to explain that when we look at the unit circle. So we'll talk about that more in the unit circle video. Okay, so tangent of 7 pi over 6. First thing we need to do is figure out what quadrant it's in. So to do that, we can convert it to degrees. So 7 pi over 6, we're going to convert it to degrees, divide it by pi, multiply it by 180. So the pi's are going to cancel. And then I'm just going to do that in my calculator. 7 times 180 divided by 6 gets me 210. So what quadrant is 210 in? Well, quadrant 210 is going to be in quadrant 3. So I think, okay, in quadrant 3, tangent, all students take classes. Tangent is positive. And then we have to think about our reference angle. Now, I've already said our reference angle is 30, but if you want to do the work, if that pattern, you're like, I don't see it, that's fine. We can do the work here. So my reference angle, if 210 is in quadrant 3, the closest x-axis is going to be 180. So we're going to do 210 minus 180, which gets me 30. Okay, so then I draw my special right triangle. 30 is at the top, 1, rad 3, and 2. And so I have my opposite, my adjacent, and my hypotenuse. So tangent is opposite over adjacent. So 1 over rad 3. And we need to rationalize the denominator. So my answer, tangent of 7 pi over 6, is positive. So I don't need to write that. Opposite over adjacent, so that would be rad 3 over 3. And that is your final answer. Okay, so for number 8, 17 pi over 4, we can convert that to, again, a quadrant and get like the correct degree to figure out what quadrant that's in. So we're going to do that right now. So 17 pi over 4. We know my reference angle just by looking at that denominator. My reference angle is 45 degrees. But to help us figure out what quadrant it's in, we're going to actually convert it to degrees. So pi multiplied by 180. And then I'm going to do that math in my calculator. The pi's cancel. And then we do 17 times 180 divided by 4 gets me 765. Oh, wait, 765, that is bigger than 360. So if it's bigger than 360, then we need to figure out what our coterminal angle is. Remember, coterminal is when it's bigger than 360. Reference angle is finding that angle that's like between 0 and 90. So since 765 is greater than 360, find the coterminal angle. That is between, because we want it between 0 and 360. So since 765 is greater than 360, we want to find the coterminal angle that's between 0 and 360. So what I'm going to do, remember to find your coterminal angles, is we just subtract 360. So 765 minus 360 is 405. Oh, wait, that's still bigger than 360. So I need to do the same thing, minus 360 again. And when I subtract, I get 45. Now, not only is 45 now within 0 and 360, 45 is my reference angle. I know what quadrant that's in. What quadrant is 45 degrees in? If you are thinking quadrant 1, you would be right. So in quadrant 1, cosine, well, if we go back up here, all students take classes. All of my trig functions are positive in quadrant 1. So cosine is positive. And my reference angle, well, my reference angle is 45. That is already an acute angle. So we don't have to think much about it. So then I just have to draw my triangle. I'm going to squeeze that in here. And continue to solve. So cosine is, here, let's label. Cosine is adjacent over hypotenuse, so 1 over rad 2. We're going to simplify, or we're going to rationalize the denominator. So that means my answer, cosine of 17 pi over 4, is rad 2 over 2. It's positive because it's in quadrant 1, and it's rationalized. And that's your answer. If you guys have more questions on this, please, please, please bring them to office hours. We are going to do and talk about the unit circle in the next video. So that might help you guys, but I really, really encourage you guys to focus more on this method of how we did it versus the unit circle, because next year in honors pre-calc, you guys will have to do this method instead of the unit circle. So there's that. I hope you guys have a great rest of your day. I hope you guys are doing well, staying safe. And yeah, I will see you guys, talk to you soon.